Okay, so what we just talked about in that first part was when two logs have the same base and they're being added together, we can combine their arguments using multiplication. Okay, and that works. So if you don't if you're like, why does that work? I can show you real quick why that works. So let's say I want to do log base 2 of 2 plus log base 2 of 4. Well, you already know the answer. I know the answer to what? I know when these have the same base and same argument, this value is 1, plus how many 2's get me to 4? Oh, 2 of them. So 1 plus 2 equals 3. So this whole thing equals 3. Well, there's another log problem that equals 3, especially with log base 2. And that one is log base 2 of 8. Remember, the answers to logs are exponents. So 2 to what power would get me to 8? Oh, that would get me to the third power. 2 to the third power is 8. So do you notice how these two problems both gave me an answer of 3? So if there is a way to get there quicker rather than doing the logs separately, if I could quickly get into a single log, how could they do that? What they noticed is there's something that I could do with the arguments. 2 and 4, how could I quickly get to 2 and 4? 2 times 4 is 8. So I can quickly condense those into 1, and it works. So it's kind of a shortcut. So if you see addition with the two logs, they have to have the same base, then what can we use to combine them? We can use multiplication. All right? Okay, so that's what we just talked about with, that's called the product property, the product rule. I call it the product property. On their paper here, it's called the product rule. So now, here's what I'm going to say. And this is the same thing I did in front of you during class. Okay, it says when two logs of the same base are being added, we can combine their arguments using multiplication. Okay, so what happens when we have two logs that are being subtracted? What do you think is going to happen? Like, you already know, it's not going to stay this. If adding goes with multiplication, what do you think subtraction is going to go with? What am I going to cover up that multiplication word with? Something that says what? Something that says division. So when two logs of the same base are being subtracted, you can combine their arguments using division. Ah, okay. So let's get that paper out of here. And that is called the quotient rule. When my two logs of the same base, they use m and n here, m and n, and when those two logs are being what? When they're being subtracted, I can use division. I can use division. So I see this. I see those two logs are being subtracted. So what can we use over here? We can use division. Mr. Thrasher, I see a fraction. Kids, a fraction means division. A fraction means division. So that means you can take the first log's argument divided by the second log's. Okay? So if I come over here where it says condense and to expand, they're both log base 4. Great. So what can I do with the 84 and the 12 to quickly get there? I can take the 84 and I can divide it by the 12. And that will be an argument of 7. And then whatever that turns out to be. I don't know what that value is. I know it's 1 point something. And if I figure out the exact value divided by log base 4, I'm typing that in on my calculator. Yep, 1.4 is what this turns out to be. Would you get the same thing if you type those in? Yep, but why are the properties better? Because then if I do have to go to a calculator, I'm only typing in 1 logs. Okay, logs on a calculator are not fun. Okay, expand. Expand means pull it apart. Where did it come from? Okay, so let's expand it. Thrasher, I don't see a base. Great. What is the base in that problem if you don't see it? The base is 10. If you don't see the base, it's 10. That's called a common log. So there's a lot of things it could be. So they want us to show expansion using what? They want us to show it using subtraction. So all I need you to think of, really, y'all, is when you do this, is I need you to think what are our arguments got to be that would get us to 9? When our two logs are being subtracted, well, what did we say when our two logs are being subtracted? Use division. So if these two logs are being subtracted, my arguments, I'm going to have to what with them? I'm going to have to divide them. So what divided by what is 9? And all of you probably said something similar, but whatever it is, it doesn't matter. Okay, 18 and 2. 18 divided by 2, it could be 9. 90 and 10 could be 9. I just need something that when I divide it, it's 9. So, for example, and it could be a lot of different answers, I'm going to put what I just said, 18 and 2 here. Because if I were to condense it into a single log and take it backwards, this is where it came from, this is where it could take us. Okay, so on this one, there could be a lot of different things that you could write there. Okay, all right, the power rule just says that if you have a number out front, you can move it up into the exponent. So if you have a number that's getting multiplied out front, what you can do is you can move it. We can move this into the exponent. Okay, so do you notice where the n is right here? Do you notice how the n is up in the exponent? If you see anything out front, you can multiply that up in the exponent. Okay, and then you can evaluate it all at once. So let's condense this. Condense means, oh, what do I see? I see a number with a product out front. I can move it up into the exponent, so it looks like this. Log base 3 of 8 squared. What is 8 squared? 8 squared is 64. I have no idea what log base 3 of 64 is. It'll be like 3 point something, but I don't know. So if you have something out front, you can move it up to the exponent. Okay. This guy says to expand it. Okay, expand it means just take it in reverse. If it's in the exponent, you could also move it out front. It just depends on where do you want it. Do you want it in the exponent or do you want it out front? So you can move it back and forth. You can put your couch wherever. Left side of the room, right side of the room. You can move it back and forth. So you can either put it in the exponent or you can put it out front. Exponent, out front. Whereas this guy, he's in the exponent. So could you move it out front? Could it possibly be x minus 1 times log base 2 of 6? Yeah, that would also work. So you can move things back and forth. If you don't like it in the exponent, move it out front. If you don't like it out front, move it up to the exponent. That's all the power property says, or the power rule says. You can move stuff. You can move stuff. Okay, what does the quotient rule say? If you see subtraction, use division. What does the product rule say? If you see addition, use multiplication. What does the power rule say? You can move stuff. What is the change of base formula? The change of base formula is specifically designed for your calculator. Okay, because you are programmed in base 10. Okay, so the calculator is programmed in base 10. So when I enter stuff on a calculator, for a calculator, I can't just enter it like normal. Okay, so if I want to enter this on the calculator, what I have to do is I have to separate it into 2 logs. Log of the argument, you got to put the argument first. Alphabetical order, A comes before B. So you got to take the 2 logs and you're going to divide them. And that's called the change of base formula. Okay, because in this calculator, when you use this thing, I've got to change the base. I can't just type in, what is the example it gives me over here? I can't just type in log base 7 of 32. Okay, now kids, here's what I'm going to tell you. As you get better with logs, you kind of know where the answer should be. Like, I know this has got to be 1 point something. I don't know what it is though. How many 7s will it take to get me to 32? Well, 1 7 gets me to 7. 2 7s get me to 49. So if you notice that, then remember the answers to logs are exponents. 1 got me to 7, 2 got me to 49. So it's 32. 32's in there somewhere in between. So my answer is going to be somewhere in between there. So when I enter this on the calculator, I've got to use, it says, using common base, explain how to evaluate the expression below. So on my calculator, I got to go type in log of 32 divided by log of 7. I can't just type in the log button on this calculator. Okay, on your phone is the same way. Okay, so if you're like, oh, how do I enter logs in on the phone? I can show you that too. So I'm going to go log 32, hit the divide button. The divide gives you the line because the line means divide, which means a fraction. Divided by, I think 7 was our base. Put the 7 in last. The base goes in last. Order matters, everybody. Oh, I was right. 1.78. Amazing. 1.78. If you want all the decimals, copy them. I only need 1 or 2. So I'm going to take 1.78 and I'm going to write that down. Okay, great. What's the last thing it says? Oh, remember, base 10 logs are common logs and written without a base. This is considered a common log. Log of 100. This is a common log. Thrasher, I don't see the base. If you don't see the base, remember, it's base 10. If the base isn't written there, it's base 10.